S. Chan presents Educational Video Lectures. Difficult concepts made easy. Study anywhere, anytime.
Welcome to S. Chan Academy, and I am Dr. Anmol Bhatia. We are covering the course Applied Thermodynamics, and the topic for this video is refrigerant and their properties.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box.
Although we have covered the basic details about refrigerant in our previous video, if you haven't watched that video, you can visit the playlist of S. Chan Academy channel. So the topic is refrigerant properties and basically what criterias are there for selection of these refrigerants. So there are certain criterias or following requirements of choosing the refrigerant. One characteristic is that it should have the stable thermodynamic and thermophysical properties. So there must be stable thermodynamic properties. Environmental and safety properties should be there. That means it would not harm the environment, it will not lead to global warming, it should not cause ozone depletion, and additionally economics should be there. That means it should be economically viable, it should not be so much costly, so it should adhere to the cost aspects as well. Now if we talk about the thermodynamic physical properties which are related to that refrigerant, the first and foremost property is the suction pressure, because it would be used in the refrigerating system. So at a given evaporated temperature, the saturation process or the saturation pressure should be above the pressure of the prevention of air or moisture which would be there in the system. So it should have the ease of higher sucking pressure. Then the discharge pressure, at a given condenser temperature, the discharge pressure should be small as it would be there, and there must be a smaller pressure ratio. So pressure ratio should be as small as possible. Then what we have, the latent heat of vaporization. The latent heat of vaporization should be as large as possible, so that the mass flow which is required per unit cooling capacity, that should be small. And in addition to these properties, there are certain other properties as well, which would be the isentropic index of the compression, that should be as small as possible. The specific heat, the liquid specific heat, that should be small, so that the degree of subcooling will be large, and smaller amount of flash gases should be there. And ultimately there must be that vapor specific heat, that should be as large as possible, so as to have the degree of superheating, that should be smaller. Then you have thermal conductivity. So thermal conductivity in both the liquid as well as in the vapor form should be as high. Viscosity should be small, it should not be so much thick and viscous, and these thermodynamic properties are basically dependent on the normal boiling point and the molecular weight and the structures. Now if I talk about ozone depletion and global warming, there are certain environmental and the safety protocols and practices that should be used. One thing is ozone depletion potential. The government nowadays are focusing on those particular types of refrigerant that has zero ozone depletion potential. That means these refrigerants should not be such that it should deplete the environment or ozone layer. So according to the protocol, this should be zero, and there should not a non-ozone depletion substance. So non-zero that ozone depletion potential has been already being phased out, and these are basically R11, R12, and they are phased out in the future, let's say R22. The government has a strict compliances that no R22 is to be used because it has chlorofluorocarbons in it. If chlorine is there, so we have already discussed in the previous videos that how chlorine basically combines with this ozone and then depletes the environment. So one potential was ozone depletion potential. The next potential is this global warming potential, that can be GWP. So global warming potential as prescribed by the protocols, it should be close to 0, but that should be as low as possible. So every refrigerant may have this global warming potential, but this global warming potential should be as low as possible, and there is a need to minimize this problem of this global warming. So refrigerant with 0 ozone depletion potential and high value of this global warming potential, let's say this R134 is that particular refrigerant that is having a high value of global warming potential, is directed to be regulated in the future. So this kind of refrigerant, which is R134A, that is to be regulated in the future, and we are looking for certain aspects in which this can be replaced. And another parameter is total equivalent warming index, which is TEWI, and that is considered to be both direct and indirect. So what comes under direct? It basically releases into the atmosphere, and indirect case is it should not release the particular aspect into the environment through any energy consumptions that can contributes because of the refrigerants by the global warming. So this is one of the aspect of selecting a refrigerant in terms of the environmental safety protocols. Now another thing is toxicity. It should not be toxic. This ideal one should not be toxic. It should not lead to the formation of certain fumes, or you can say it should not occupy much space in general. So it should not be hazardous to the environment again. Its flammable properties should be such that it should be non-flammable and non-explosive, and we have taken such particular precautions to avoid those accidents. And chemically it should be stable. It should not change its form while reacting with another substances, and it should be compatible with the it should have no reaction with particular metals and non-metals. It should be compatible with those kind of cases. And miscibility with the lubricating oils, as you know that the lubricating oil is basically used, so it should not be mixed with those lubricating oils. And if it leaks, so there should be ease of leakage detections. So there must be ways in which we detect the leakage of that particular refrigerant into the environment. So we stop here for a short break. After coming back from the break, we will learn the properties of different refrigerants which are used in industry.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back to S. Chand Academy channel after the break. So far we have learnt about refrigerants and its properties. Now in this part we will be learning about the eco-friendly refrigerants and we'll look at certain properties. So if categorically if we categorize these alternatives to CFCs, these alternatives can be HCFCs, that can be refrigerants like R22, R124, HFCs which can be R134A, R152A, or certain natural refrigerants like ammonia or hydrocarbons. So we'll look at certain aspects, like if we look at R22, so ozone depletion potential is this much value. That means although this depletion potential is very small, but as per the protocol it should be 0. So if it is not 0, then we have to strike it off, and global warming potential is around 1700. So it has 40% more refrigerating capacity, and it has high pressure and discharge temperature, but it is not suitable for the low temperature applications. It is extensively used in commercial air conditioning and frozen food storage and those display cases. In the previous times, okay. Now R123A, although ozone depletion potential is there, but the global warming potential is also 90, and it is basically the replacement of R11, and it has the similar thermodynamic property, and it has very short atmospheric life, and it is a retrofit alternative to R11. Then if we talk about this R134A, although it has zero ozone depletion potential, but it has a global warming potential value of 1300. That means scientists are continuously in the search of an alternative that should have this zero ozone depletion potential, and this global warming potential should be as low as possible. It is basically a substitute to R12 and R22 to a limited range, and it has good performance in medium and high temperature applications. Toxicity in this particular aspect is very low, and it is non-miscible with the mineral oils. So it is not mixed with the mineral oil, which are particularly the major property which is required in the lubricants. Then R152A, another refrigerant in the same category. So global warming potential is lesser, ozone depletion potential is lesser, and it is very attractive to this HFC, which is having similar property of R12. So as I have told you that we are in the continuous search of an alternative which is having a lesser value of the global warming potential. So this global warming potential is one order lesser than this, that 134A, but it is slightly flammable, this one. So if it is flammable, then it is also not acceptable, and also it has lower energy consumptions, and hence these energy consumption values are lesser. So this Environmental Protection Agency of Europe prefers this R152A than 134A. So if I compare both of them, so in the European agency, as per this European Protection Environment Agency, R152A is basically used. Then R290, this is another categorization. So global warming potential very less, ozone depletion potential is 0, it is compatible with copper, mineral oils, it is miscible, and it has highest latent heat, and that vapor density is also very large, and it is a third of the original charge only when it is required in replacement of this hydrocarbons and the refrigerant in the existing equipments. It is basically energy saving up to 20% due to the lower molecular mass value and high vapor pressure values. Then carbon dioxide, naturally occurring, it is zero ozone depletion value, zero global warming potential is particularly there, but it is non-flammable and non-toxic, inexpensive and widely available, and high operating pressures are there, and it is used for that particular operation where you have the weight reducing potential. The major drawback is operating pressure is only 80 bars and it has low efficiency. So there is no point of using this particular carbon dioxide because the operating pressure is very low. So with this we come to the end of the video, wherein we learnt about certain properties of the alternatives to chlorofluorocarbons, and there are certain properties which are as per the protocols of safety. Thank you.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.